Chapter 10 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Greg Bell. Curiosities of the Sky by Garrett Serviss. Chapter 10. Strange Adventures of Comets. The fears and legends of ancient times before science was born, and the superstitions of the Dark Ages, sedulously cultivated for theological purposes by monks and priests, have so colored our ideas of the influence that comets have had upon the human mind that many readers may be surprised to learn that it was the apparition of a wonderful comet, that of 1843, which led to the foundation of our greatest astronomical institution, the Harvard College Observatory. No doubt the comet superstition existed half a century ago, as indeed it exists yet today, but in this case the marvelous spectacle in the sky proved less effective in inspiring terror than awakening a desire for knowledge. Even in the 16th century, the views that enlightened minds took of comets tended powerfully to inspire popular confidence in science, and Halley's prediction, after seeing and studying the motion of the comet which appeared in 1682, that it would prove to be a regular member of the Sun's family, and would be seen returning after a period of about 76 years, together with the fulfillment of that prediction, produced a revulsion from the superstitious notions which had so long prevailed. Then the facts were made plain, that comets are subject to the law of gravitation equally with the planets, that there are many which regularly return to the neighborhood of the Sun, perihelion, and these travel in orbits differing from those of the planets only in their greater eccentricity. Although they have the peculiarity that they do not, like the planets, all go around the Sun in the same direction, they do not keep within the general plane of the planetary system, but traverse it sometimes from above and sometimes from below. Other comets, including most of the great ones, appear to travel in a parabolic or, in few cases, hyperbolic orbits, which, not being closed curves, never bring them back again. But it is not certain that these orbits may not be extremely eccentric ellipses, and that after the lapse of hundreds or thousands of years, the comets that follow them may not reappear. The question is an interesting one, because if all orbits are really ellipses, then all comets must be permanent members of the solar system, while in the contrary case, many of them are simply visitors, seen once and never to be seen again. The hypothesis that comets are originally interlopers might seem to derive some support from the fact that certainly periodic ones are associated, in groups, with the great outer planets, whose attraction appears to have served as a trap for them by turning them into elliptical orbits, and thus making them prisoners in the solar system. Jupiter, owing to his great mass and his commanding situation in the system, is the chief comet catcher, but he catches them not for himself, but for the Sun. Yet if comets do not come originally from without the borders of the planetary system, it does not by any means follow that they were wanderers at large in space before they yielded to the overmastering attraction of the Sun. Investigation of the known cometary orbits, combined with theoretical considerations, has led some astronomers to the conclusion that as the Sun travels onward through space, he picks up en route cometary masses, without belonging strictly to his empire, are borne along in the same vast cosmical current that carries the solar system. But while no intelligent person any longer thinks that the appearance of a great comet is a token from the heavenly powers of the approaching death of a mighty ruler, or the outbreak of a devastating war, or the infliction of a terrible plague upon wicked mankind, science itself has discovered mysteries about comets, which are not less fascinating because they are more intellectual than irrational fancies than they have displaced. To bring the subject properly before the mind, let us see what the principal phenomena connected with the comet are. At the present day, comets are ordinarily picked up with the telescope or the photographic plate before anyone except their discoverer is aware of their existence, and usually they remain so insignificant in appearance that only astronomers ever see them. Yet so great is the prestige of the word comet, that the discovery of one of these inconspicuous wanderers and its subsequent movements become items of the day's news which everybody reads with the feeling, perhaps, that at least he knows what is going on in the universe, even if he doesn't understand it. But a truly great comet presents quite a different proposition. It too is apt to be detected coming out of the depths of space before the world at large can get a glimpse of it. But as it approaches the sun, its aspect undergoes a marvelous change. Agitated, apparently by solar influence, it throws out a long, streaming tail of nebulous light, directed away from the sun and looking as if blown out like a pennon by a powerful wind. Whatever may be the position of the comet with regard to the sun, as it circles round him it continually keeps its tail on the off side. This, as we shall soon see, is a fact of the capital importance in relation to the probable nature of comets' tails. Almost at the same time that the formation of his tail is observed, a remarkable change takes place in the comet's head, which, by the way, is invariably and not merely occasionally its most important part. On approaching the sun, the head usually contracts. Coincidentally, with this contraction a nucleus generally makes its appearance. This is a bright, star-like point in the head, and it probably represents the totality of the solid matter that the comet possesses. But it is regarded as extremely unlikely that even the nucleus consists of a uniformly solid mass. If it were such, comets would be far more formidable visitors when they pass near the planets than they have been found to be. The diameter of the nucleus may vary from a few hundred up to several thousand miles. The heads, on average, are from 25,000 to 100,000 miles in diameter. Although a few have greatly exceeded these dimensions, that of the comet of 1811, one of the most stupendous ever seen, was 1,125,000 miles in diameter. As to the tails, notwithstanding their enormous length, some have more than 100 million miles long, there is reason to believe that they are of extreme tenuity, as rare as vacuum. The smallest stars have been seen shining through their most brilliant portions with undiminished luster. After the nucleus is formed, it begins to throw out bright jets directed towards the sun. A stream, and sometimes several streams of light, also project sunward from the nucleus, occasionally appearing like a stunted tail, directed oppositely the real tail. Symmetrical envelopes, which seen in section, appear as half-circles or parabolas, rise sunward from the nucleus, forming concentric series. The ends of these stream backwards into the tail, to which they seem to supply material. Ordinarily, the formation of these ejections and envelopes is attended by intense agitation of the nucleus, which twists and turns, swinging and gyrating, with an appearance of the greatest violence. Sometimes the nucleus is seen to break up into several parts. The entire heads of some comets have been split asunder and passing close around the sun. The comet of 1882 retreated into space after its perihelion passage with the 5 heads instead of the 1 that it had originally, and each of these heads had its own tail. The possession of the spectroscope has enabled astronomers during later years to study the chemical composition of comets by analyzing their light. At first, the only substances thus discovered in them were hydrocarbon compounds, due evidently to the gaseous envelopes in which some combinations of hydrogen with carbon existed. Behind this gaseous spectrum was found a faint continuous spectrum ascribed to the nucleus, which apparently both reflects the sunlight and gives forth the light of a glowing solid or liquid. Subsequently, sodium and iron lines found in cometary spectra. The presence of iron would seem to indicate that some of these bodies may be much more massive than observations on their attractive effects have indicated. In some recent comets, such as Morehouse's in 1908, several lines have been found, the origin of which is unknown. Without going back to the 19th century, we may find records of some of the most extraordinary comets that man has ever looked upon. In 1811, still spoken of as the year of the comet, because of the wonderful vintage ascribed to the skyey visitor, a comet shaped like a gigantic sword amazed the whole world, and, as it remained visible for 17 months, was regarded by superstitious persons as a symbol of the fearful happenings of Napoleon's Russian campaign. This comet, the extraordinary size of whose head, greatly exceeding that of the sun itself, has already been mentioned, was also remarkable for exhibiting so great a brilliancy without approaching even to the Earth's distance from the sun. But there was once a comet, and only once, in the year 1729, which never got nearer to the sun than 4 times the distance to the Earth, and yet appeared as a formidable object in the sky. As Professor Young has remarked, it must have been an enormous comet to be visible from such a distance, and we are to remember that there were no great telescopes in the year 1729. That comet affects the imagination like a phantom of space peering into the solar system, displaying its enormous train afar off, which, if it had approached as near as the comets, would have probably become the celestial wonder of all human memory, and then turning away and vanishing into the depths of immensity. In 1843, a comet appeared which was so brilliant that it could be seen in broad day close beside the sun. This was the first authenticated instance of that kind, but the occurrence was to be repeated, as we shall see in a moment, less than 40 years later. The splendid comet of 1858, usually called Donati's, is remembered by many persons yet living. It was, perhaps, both as seen by the naked eye and with a telescope, the most beautiful comet of which we have any record. It, too, marked a rich vintage year, still remembered in the vineyards of France, where there is a popular belief that a great comet ripens the grape and imparts to the wine a flavor not attributable by mere skill of the cultivator. There are comet wines, carefully treasured in certain cellars, and brought forth only when their owner wishes to treat his guests to a sip from paradise. The year 1861 saw another very remarkable comet, of an aspect strangely vast and diffuse, which is believed to have swept the earth with its immense tail when it passed between us and the sun on the night of June 30th, an event which produced no other known effect than the appearance of an unwonted amount of scattered light in the sky. The next very notable comet was the Great Southern Comet of 1880, which was not seen from the northern hemisphere. It mimicked the aspect of the famous comet of 1843, and to the great surprise of astronomers, appeared to be traveling in the same path. This proved to be the rising of the curtain for an astronomical sensation unparalleled in its kind. For 2 years later another brilliant comet appeared, first in the southern hemisphere, and it too followed the same track. The startling suggestion was now made that this comet was identical with those of the 1843 and 1880, its return having been hastened by the resistance experienced in passing twice through the coronal envelope, and there were some who thought that it would now swing swiftly round and then plunge straight into the sun, with consequences that might be disastrous to us on account of the flash of the heat that would be produced by the impact. Nervous people were frightened, but observation soon proved that the danger was imaginary, for although the comet almost grazed the sun, and must have rushed through 2 or 3 million miles of the coronal region, no retardation of its immense velocity was perceptible, and it finally passed away in a damaged condition, as before remarked, and has never since appeared. Then the probable truth was perceived, that the 3 comets, 1843, 1880, and 1882, were not one identical body, but 3 separate ones, all traveling in the same orbit. It was found, too, that a comet seen in 1668 bore similar insignia of relationship. The natural inference was that these 4 bodies had once formed a single mass that had been split apart by the disruptive action of the sun. Strength was lent to this hypothesis by the fact that the comet of 1882 was apparently torn asunder during its perihelion passage, retreating into space in a dissevered state. But Professor George Forbes has a theory that the splitting of the original cometary mass was effected by an unknown planet, probably greater than Jupiter, situated at 100 times the Earth's distance from the sun, and revolving in a period of 1,000 years. He supposes that the original comet was not that of 1668, but one seen in 1556, which has since been missing, and its description occurred from an encounter with a supposititious planet about the year 1700. Truly, from every point of view, comets are the most extraordinary adventurers. The comet of 1882 was likewise remarkable for being visible, like its predecessor of 1843, in full daylight in close proximity to the sun. The story of its detection when almost in contact with the solar disk is dramatic. It had been discovered in the southern hemisphere only a couple weeks before its perihelion, which occurred on September 17th, and on the forenoon of that day it was seen by Dr. Common in England, and by Dr. Elkin, Mr. Finlay, and the Cape of Good Hope, almost touching the sun. It looked like a dazzling white bird with outspread wings. The southern observers watched it go right into the sun, when it instantly disappeared. What had happened was that the comet, in passing its perihelion point, had swung exactly between the Earth and the sun. On the following morning, it was seen from all parts of the world, close by the sun on the opposite side, and it remained thus visible for 3 days, gradually receding from the solar disk. It then became visible for northern observers in the morning sky before sunrise, brandishing a portentous sword-shaped tail, which, if it had been in the evening sky, would have excited the wonder of hundreds of millions, but situated where it was, comparatively few ever saw it. The application of photography to the study of comets has revealed many curious details which might otherwise have escaped detection, or at best have remained subject to doubt. It has in particular shown not only the precise form of the tails, but the remarkable vicissitudes that they undergo. Professor Barnard's photographs of Brooks' comet in 1893 suggested by the extraordinary changes in the form of the tail which they revealed, that the comet was in a series of obstructions in space, which bent and twisted its tail into fantastic shapes. The reader will observe the strange form into which the tail was thrown on the night of October 21st. A cloud of meteors through which the comet was passing might have produced such deformations of its tail. In the photograph of Daniel's comet of 1907, a curious striping of the tail will be noticed. The short bright streaks seen in the photograph, it may be explained, are the images of stars which are drawn out into lines in consequence of the fact that the photographic telescope was adjusted to follow the motion of the comet while the stars remained at rest. But the adventures of comets are not confined to possible encounters with unknown obstacles. We have referred to the fact that the great planets, and especially Jupiter, frequently interfere with the motions of comets. This interference is not limited to the original alteration of their orbits from possible parabolas to ellipses, but is sometimes exercised again and again, turning the bewildered comets into elliptical paths of all degrees of eccentricity. A famous example of this kind of planetary horseplay is furnished by the story of Lexell's missing comet. This comet was first seen in 1770. Investigation showed that it was moving in an orbit which should bring it back to the perihelion every 5.5 years. Yet it had never been seen before, and although often searched for, has never been seen since. Laplace and Leverrier proved mathematically that in 1767 it approached so close to Jupiter as to be involved among the orbits of its satellites. What its track had been before is not known, but on that occasion the giant planet-sized interloper threw it into a short elliptic orbit and sent it, like an arrested vagrant, to receive the sentence at the bar of the sun. On this journey it passed within less than 1.5 million miles of the Earth. The form of orbit which Jupiter had impressed required, as we have said, its return in about 5.5 years. But soon after 1770 it had the misfortune, a second time, to encounter Jupiter at close range, and he, as if dissatisfied with the leniency of the sun, or indignant at the stranger's familiarity, seized the comet and hurled it out of the system, or at any rate, so far away that it has never since been able to rejoin the family circle that basks in the immediate rays of the solar hearth. Nor is this the only instance in which Jupiter has dealt summarily with small comets that have approached him with too little deference. The function which Jupiter so conspicuously fulfills, as master of the hounds to the sun, is worth considering a little more in detail. To change the figure, imagine the sun in its voyage through space to be like a majestic battleship surrounded by its scouts. Small vessels, the comets, as they are overhauled by the squadron, are taken in charge by the scouts, with Jupiter for their chief, and are forced to accompany the fleet, but not all are impressed. If a strange comet undertakes to run across Jupiter's bows, the latter brings it to, and makes prize of it by throwing it in a relatively small ellipse with the sun for its focus. Thenceforth, unless as happened to the unhappy comet of Lexell, it encounters Jupiter again in such a way as to be diverted by him into a more distant orbit. It can never get away. About 30 comets are now known to have thus been captured by the great planet, and they are called Jupiter's comet family. But on the other hand, if a wandering comet crosses the wake of the chief planetary scout, the latter simply drives it away by accelerating its motion and compels it to steer off into open space. The transformation of comets into meteors will be considered in the next chapter, but here, in passing, mention may be made of the strange fate of one member of Jupiter's family, Biela's comet, which, having become overbold in its advances to its captor, was, after a few revolutions in its impressed orbit, torn to pieces and turned into a flock of meteors. And now, let us return to the mystery of comets' tails. That we are fully justified in speaking of the tails of comets as mysterious is proved by the declaration by Sir John Herschel, who averred in so many words that there is some profound secret and mystery of nature concerned in this phenomenon, and this profound secret and mystery has not yet altogether been cleared up. Nevertheless, the all-explaining hypothesis of Arius offers us once more a certain amount of aid. Comets' tails, Arius assures us, are but another result of the pressure of light. The reader will recall the applications of this theory to the zodiacal light and the aurora. In the form in which we now have to deal with it, the supposition is made that as a comet approaches the sun, eruptions of vapor, due to solar heat, occur in its nucleus. These are naturally most active on the side which is directly exposed to the sun, whence the appearance of the immense glowing envelopes that surround the nucleus on the sunward side. Among the particles of hydrocarbon, and perhaps solid carbon, in the state of fine dust, which are thus set free, there will be many whose size is within the critical limit which enables the light waves from the sun to drive them away. Clouds of such particles, then, will stream off behind the advancing comet, producing the appearance of a tail. This accounts for the fact that the tails of comets are always directed away from the sun, and it also explains the varying forms of the tails and the extraordinary changes that they undergo. The speed of the particles driven before the light waves must depend upon their size and weight, the lightest of a given size traveling the most swiftly. By accretion, certain particles must grow, thus losing velocity and producing the appearance of bunches in the tail, such as has been observed. The hypothesis also falls in with researches of Bredichin, who have divided the tails of comets into three principal classes. 1. Those who appear as long, straight rays. 2. Those which have the form of curved plumes or scimitars. 3. Those which are short, brushy, and curved sharply backward along the comet's path. In the first type, he calculates the repulsive force at from 12 to 15 times the force of gravity, in the second at from 2 to 4 times, and in the third about 1.5 times. The straight tails he ascribes to hydrogen because hydrogen atom is the lightest known, the sword-shaped tails to hydrocarbons, and the stumpy tails to vaporized iron. It will be seen that, if the force driving off the tails is that which Arius assumes it to be, the forms of those appendages would accord with those of the Bredichin theories called for. At the same time, we have an explanation of the multiple tails with which some comets have adorned themselves. The comet of 1744, for instance, had at one time no less than 7 tails spread in a wide curved brush behind it. Donati's comet of 1858 also had at least 2 tails, the principal one sword-shaped and the other long, narrow, and straight as a rule. According to Bredichin, the straight tail must have been composed of hydrogen, and the other of some form of hydrocarbon, whose atoms are heavier than those of hydrogen, and consequently, when swept away by the storm of light waves, followed a curvature depending upon the resultant forces operating upon them. The 7 tails of the comet of 1744 presented a kind of diagram graphically exhibiting its complex composition. If we knew a little more about the constituents of a comet, we might be able to say from the amount of curvature of the different tails just what were the 7 substances of which that comet consisted. If these theories seem to be rather fantastic, at any rate they are no more fantastic than the phenomena that they seek to explain. End Chapter 10. Greg Bell, Katy, Texas.